Hi, everybody. Welcome back to the second half of this chapter, actually the second part, because we're going to do this one in three parts. So again, we were talking about these subduction zones and kind of where we get these volcanic arcs. And so here are three examples of them, where we see Mount Fuji in Japan, the Cascade Mountains of the Pacific Northwest, the Aleutian Mountains in Alaska. These are all part of that ring of fire that I mentioned previously. And so the Ring of Fire circles around the Pacific Ocean, and this is where you're getting the majority of earthquakes. Is very, very volcanically active. And so here you can see those Cascade Mountains up here, where we have Mount St. Helens, which we'll talk about in a minute. Those the Aleutian Mountains in Alaska, and Japan, which is also highly volcanically active, and we'll talk about tsunamis and earthquakes in the last part of this chapter. Here is where the 2004 earthquake and tsunami that killed over 100,000 people. So we'll talk a little bit about that more as we move on. But just to talk a little bit again about that continent on continent collision. So the crust is folding upwards. You have no subduction. So here is India is kind of crashing into this plate up here, and you get the Himalayan mountains, right? These huge mountains that are forming, right? These things are just pushing together and being pushed up. When you get a continent on continent collision, you get very, very tall mountains like the Himalayas. But you don't get any active volcanoes here because there's no subduction that's happening. You kind of get remnants of some active volcanoes underneath it, though, but no active volcanoes. We also get something called hotspots, which is not where you're getting subduction, but it's basically just a weak spot in the crust. So you have this stationary spot that you have magma rising up. It's just a weak part of the crust, and this is what's formed the Hawaiian Islands. And so this weak spot is not moving, but the crust over it is moving, right? And so this plate is moving in this direction. And so here's the big island of Hawaii, which is currently over this hot spot. These other islands, Maui, Molokai, Oahu, and Kauai, those used to be over the hot spot when they were formed. So the farther you're away from the hot spot, the older the island is. And the newest island is the big island of Hawaii. So the plate is moving on top of that hot spot, and you can see here this plate is moving, and so you're getting these new islands that are formed. The Midway Islands that are to the west are 27 million years old. So you get these incredibly long island chains. The Hawaiian Islands, we have the major ones that we know about, but the actual Hawaiian Islands go on for quite some distance. So you get volcanoes that form over that hot spot, and that as that plate moves the volcano off the hot spot, that volcano then becomes extinct. It's no longer going to erupt. And a new volcano will form in its place. So eventually, the big island of Hawaii will move off of this hot spot, and you will get a new island that will be formed. And so over time, you get a chain of volcanoes. This is not a volcanic arc like we have with the Cascades, where you're having subduction that's happening and all these volcanoes popping up. This is a different type of volcano. Only active at the hot spot, right? This used to be a volcano. This used to be a volcano. If you've been to Oahu, where Honolulu is, you can see the old crater of the volcano, but there's nothing active in there right now. And so this picture I actually took at Volcanoes National Park, which shows kind of here is that hot spot, that plume. So you have the big island of Hawaii has Mauna Loa and some other smaller volcanoes. Maui has a past connection, but still has a little bit of activity. But you can see the plate was moving this way off of this hot spot. these islands used to be active volcanoes, but they no longer are. And here is, there's me on lava flow in Hawaii, right? This is very, very new land. I think this lava flow is about 20 years old, if I'm correct. But you can see this very, very new volcanic rock. Terranes are another type of landform that happens. This is when extinct volcanic arcs are accreted or kind of pushed onto continents. And so what you have here is a volcanic arc that was out in the ocean. As this plate moved over and moved over, eventually this gets accreted on to the continent. So they were formed earlier and far away. And we can tell this because of the age and the composition of rocks, right? This island arc that it got accreted on is much older than this volcanic arc right here that formed because of this subduction. So when we look at the long-term history of plates, and again, you'll watch a video, Pangaea is only that most recent supercontinent. Continents keep breaking apart and slamming back together. It will happen again, and that video that you'll watch outside of this lecture will show how that will happen again and kind of where things will be. It's a model, what they think based upon the movement that's happening today. So again, Pangaea 200 million years ago, which is the latest one, when all this was connected. Eventually, all of these guys will wind up slamming back into each other again. So again, volcanic landforms, we're going to talk a lot about volcanoes, are just lava or magma that is cooling into new rock formations. Different materials make different landforms. And this often occurs on the seafloor. Often you're getting magma that's rising up. Excuse me, I'm losing my voice. Magma that's rising up. And as soon as it forms, it gets high enough, it will poke out of the ocean. Here is a new island that is recently formed, right? As soon as it gets high enough to poke itself out of the ocean, you get a new island. And like I said before, these often happen over hotspots like with the Hawaiian Islands. So this is Surtsey Island in Iceland. It was an island born in 1963 is when it first popped out of the water. So we have three categories of volcanoes, active, dormant, and extinct. Active means that there's still magma underneath it and it will still erupt. Dormant means there is no eruptions in a very long time and it may be extinct. Often we're not sure. It may never erupt again, but it might, but it just has not erupted in a very, very long time. And extinct means there is no longer any magma chamber underneath, so it's definitely not going to erupt. Because either that subduction boundary has fused together or that volcano has moved off of that hotspot. And you cannot tell just by looking, right? So if you look at these two pictures, you might want to say, okay, which one is the active volcano? Which one is the extinct one? This is Mount Kilimanjaro, which is a dormant volcano, hasn't erupted in a very, very long time, likely will not erupt again. And here is Mount Rainier, which is very, very dangerously active. Mount Rainier is definitely going to erupt again at some point, has a very active magma chamber underneath it. And if you look, Mount Rainier is very, very close to where people live. I took this picture out of an airport window. But again, if that volcano has to be monitored very closely because it's very, very close to where a lot of people are living. A few types of volcanoes. So the first one is composite volcanoes, also known as stratovolcanoes. They are usually in subducted zones. Mount St. Helens, which erupted when I was a kid, is a composite volcano. And what's happening there is you get a lot of compressed gas and water underneath the surface, and they have very explosive eruptions. So it's not this kind of slow eruption where lava is just flowing out. You get this big explosion of gas and water and debris that happens all at once. So you get these ash clouds that rain down on the flanks of a volcano. known as pyroclastic flows. There's a video of it that you'll watch outside of this lecture. You also get this thick, heavy lava that is called andesitic, but the main damage from these eruptions are this pyroclastic flow that happens. This thick, heavy lava, because it's so thick, it just kind of dribbles down. It doesn't really flow very far before it cools. It's moving very, very slowly. And so you wind up with these very steep sided cone-shaped mountains, volcanoes, excuse me. And so here is a time lapse of Mount St. Helens, of pictures erupting. The pressure built up and it actually exploded out of the side. So you can see here where that explosion happened. Quite devastating, this landslide that happened and this pyroclastic flow. Again, this stuff that's coming out is extraordinarily hot. I very much remember watching on network television kind of the aftermath of this. They knew it was going to erupt. They could see that side of the mountain start to bulge out. And so most people were evacuated. People that were killed from this were people who chose not to leave. So just a reminder, if somebody's telling you to evacuate, probably a good idea and you should do it. I also want to talk a little bit about calderas. Calderas are collapsed craters that happen after large eruptions. So you have a huge amount of material that's ejected, like the Mount St. Helens eruption. Crater Lake in Oregon is another example of that. This one formed a lake from this deep depression afterwards. So again, you have a volcano here that's erupted, it's ejected all of this material, and so now you have a depression, sometimes that will fill with water. Eruptions are still happening here, right? Despite the fact that there's a lake on top of this volcano, it's still going to erupt. Shield volcanoes are a different type of volcano, and that's an example of Mauna Loa in Hawaii. We have this very thin liquidy lava, which is basaltic. It's not andesitic like that thick lava. It's much thinner. You have very little compressed gas that's happening. You get quiet, relatively peaceful eruptions, and you get lava flows really far down from the slope. It's still, it moves fast, but not that fast, right? It's not going to like overtake you. When I spent a summer in Hawaii doing some research, and some of the people who I stayed with had gone and seen these lava flows, had all kinds of neat stuff that they had kind of dipped into it, and which is pretty dangerous. But right now, or when I was there a few years ago, the only active lava flows were on private property, so you couldn't go see them, but sometimes they're happening on public land and you might be allowed to get close enough in order to see it. But again, you're going to get these very gentle sloping sides that are happening because you have this thin liquidy lava that kind of flows a long distance. So you get these big round domes with very gentle sloping sides. They are associated with hotspots and divergent boundaries. So unlike that convergent boundary where you're getting probably subduction, these are just kind of, you have this magma that's just rising, it's very thin and liquidy, and it's just flowing over the sides. So again, here's a picture of Mauna Loa in Hawaii. If you didn't really know exactly what you were looking for, you might not even realize that that is a volcano. Mauna Loa is extraordinarily high, though, right? It rises from the ocean floor. Here is Mount Rainier, that's 14,000 feet above sea level, but Mauna Loa is much, 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 much taller than Mount Rainier. It's just most of it is below the ocean. There are some other basaltic lava formations that we get. We get flood basalts, which are kind of these large layered lava flows. They're not necessarily mountains. We get that in Yellowstone, in the Columbia Plateau, and the Pacific Northwest, which is here. This is all from just lava flows. We also get those mid-ocean ridges. Again, we have those divergent plate boundaries that are pulling apart, and then you're getting lava that's rising up. Iceland is a hot spot on a mid-ocean ridge, so you get lots of lava flows here that are happening, but they're not that volcano that's going to erupt. Yellowstone is actually a supervolcano, which if you watch the History Channel, they'll every once in a while have kind of specials on Yellowstone's supervolcano. But there is a huge magma chamber that is underneath Yellowstone National Park. It's bulging about 3 inches a year. We can measure that. And if the pressure is released all at once, lots of ash gets thrown into the atmosphere. So here is uh, an idea of how far that ash fall would extend, right? It would get thrown up into the air and it would rain down on a huge portion of the United States. It would block out the sun and it would really, really mess with our agriculture, which we grow tons of food in this area. Oops, sorry. And so what we know is how often it erupts. It erupts about every 600 to 700,000 years. We can see where it has erupted in the past. And so it hasn't erupted in about 600,000 years, so we're due. That doesn't mean it will erupt in our lifetime. It could erupt in another 100,000 years. But at some point, that Yellowstone supervolcano will definitely erupt. Another type of volcano is cinder cones. Cinder cones are made of mostly ash. They don't have any flowing lava at all. It's all pyroclastic. They're small. They get very, very steep sides to them. And they occur in all kinds of volcanically active places, just depending on whether or not they have flowing lava. Something else to think about, plug domes or lava domes. So you have that thick andesitic magma that's under pressure. And so here is the caldera in Mount St. Helens. And so it is actually pushing up on this and causing it to form this plug dome that's in the middle of that. It does not erupt, and they often occur as part of a bigger volcano. You can see extinct versions of plug domes, plugs that form underground, and then that extrusive rock erodes away, and you wind up seeing these extinct plug domes, which we talked about extrusive and intrusive rock in the previous module or so. So we are going to come back and talk about other types of tectonic landforms and earthquakes and tsunamis in part 3 of this chapter.